Hello ladies and gentlemen, this is Thijs, the technical evangelist at Varnish Software. I'm very proud and happy to announce the availability of the official Helm chart for Varnish Enterprise. It's a great addition to our cloud-native offering, and while we've had an official Docker image for Varnish Enterprise for a while and the recipes to orchestrate them in Kubernetes, we finally have a Helm chart, which makes all the difference. A Helm chart, what is it you may ask? Well, Helm is a package manager and template engine that allows you to deploy container workloads in Kubernetes without all the necessary complexity, taking away the need of writing these really complicated and long YAML files that Kubernetes is known for. So by simply running helm install, you can deploy Varnish Enterprise in Kubernetes. So allow me to show you how it works. To get started, make sure you have Helm installed on your computer and access to a Kubernetes cluster. Then run the helm install subcommand to get started. There is a -f parameter that allows you to reference a configuration file. This Values.yaml configuration file contains all the overrides that will eventually be injected into the templates behind the scenes. We give our install a name, Varnish-Enterprise, and we're using the Varnish/Varnish-Enterprise Helm chart to get going. Here's the content of our Values.yaml file. It contains configuration overrides that allow you to customize the install of Varnish. At the top, you'll spot the image pull secrets directive that points to a secret containing all the necessary credentials and tokens to access the private repositories. Because remember, this is Varnish Enterprise, you need to be a client and you need to have a Varnish Enterprise license before you can use this Helm chart. And if you go to our docs page on docs.varnish-software.com, there's an install guide that explains how to configure it all, how to pull in the repositories, and how to set the username and the passwords. Once you've gone through that, you'll have the Varnish pull secret, and that's the only reference you need to get access. After that, of course, you need to specify some more parameters. The fact that this is a regular deployment with a single replica and TLS enabled. That TLS is also reflected in the HTTP service being activated. And finally, there's this VCL config parameter that contains the string version of our VCL file. Now it doesn't do much. We've opted, because this is a standalone service, to just return some synthetic output. So when you finally run your helm install command with all the parameters, you'll get some output. It contains the name of the helm install, Varnish Enterprise in this case, with a deployment date and the namespace, the status, the revision, and so on and so forth. And now we can look at the Kubernetes side of things. By running kubectl get all, we get all the defined resources, and you can spot the pod that was created for Varnish Enterprise. A pod is the entity in which the containers live. So it's Varnish Enterprise with sort of a random number behind it. You can also spot the service. That's the way the endpoint of the pod gets exposed to the outside world. You'll see that port 80 and 443 are exposed, but in this case, port forwarded to some specific ports, 31901 and 32012. Knowing that the container ports were forwarded to my local system, I can now use that port forwarding to access my Varnish Helm install. Simply connect to localhost over port 32012 using HTTPS to access that service. And while the output that you get looks a bit like an error message, it really isn't. Because what you're seeing is the standard synthetic output template that Varnish generates. Remember, we called return synt200 in the VCL code, and this is what you get. However, this is not what you want to use in the real world. In fact, you want to use Varnish and put it in front of another service to cache it and accelerate it. And that's what we're going to do. We're going to take it to the next level and install this web service. I'm going to use the Echo server, which is a very easy tool to use. It just produces some meta information, and we're going to cache it. To install the Echo server, we can run the helm command again, but this is a public image, no pull secrets required. Simply run helm install and then call the install Echo server. And the helm chart we're going to use is elan echo server. We're overriding the configuration not through a values.yaml file, but just by an explicit set. We're going to set the service type to node port so we can take advantage of that port forwarding again. And when the helm install command is run, again, you'll see some familiar output, a confirmation that the helm install succeeded. And when you run kubectl get service or get svc to get all the running services, you see the addition of the echo server service, also port forwarded. The HTTP port is now port forwarded to port 30250. And when we access the Echo server over port 30250, you'll get a lot of output. This is JSON output containing meta information about the request. Now there's some particularly interesting information in there. Those happen to be environment variables setting the service port and the service hosts. So that means within the context of that execution, Every service can have access to some environment variables specifying how you can access the other services. So in this case, the Echo server is available on cluster IP 10, 106, 183, 170 on port 80. Using that information, we could take that IP address now, alter our Values.yaml file, define an actual backend in our VCL config and put the IP address there. That is one way of doing it. I prefer a more flexible way by defining the internal DNS name of that service. Every service that you define in your Kubernetes cluster comes with a predefined DNS name. It's the name of the service, then dot the namespace, dot svc.cluster.local. So in our case, that's echo-server.default.svc.cluster.local. And if the endpoints changes or the service IP changes, the DNS name remains the same. So that's the type of flexibility we're looking for. Now that we've altered the Values.yaml file and connected Varnish to the Echo server, we can redeploy that Helm chart. For that, we use the Helm upgrade command. We also specify the Values.yaml file, the name of the release, in this case that's Varnish Enterprise, and the Helm chart. And I forgot to mention it earlier, but there's also a Helm list command that gives you an overview of the releases you've made. And we see the Echo server, which is in revision 1, and Varnish Enterprise that is in revision 2, and that's because we've changed the Values.yaml file and redeployed it. And when we run kubectl get svc, we still get our Echo server and we still get our Varnish Enterprise port forwarded to exactly the same ports. So let's call the service, and instead of calling localhost 3250 to get the output as we've done previously, let's do it through Varnish. Let's call localhost on port 31901. The output still contains all that JSON, so it's hard to know whether the output came from the actual Echo server or was served through Varnish. The response headers that are served really provide the answer to that question. And when you run curl -I, a head command will be sent instead of a get command, and only the headers will be displayed. And it's the headers that tell the tale. As you can see, Varnish injects an X-Varnish header and also an age header. And it's that age header that tells how many seconds this has been stored in the cache for. So when it's greater than 0, it's served from the cache and not the cache miss. In this case, the output has been served from the cache for 5 seconds. And before we end the video, I want to show you one last time why Helm is so valuable. If you were to write the Kubernetes service yourself, you'd be looking at writing a ton of YAML configuration. And we can actually see how much configuration that is by running Helm template and sending the output of our Helm chart to a YAML file. Looking at it, you'd have to define the service account yourself, and the config map yourself, and the service, and a very lengthy deployment configuration that seems to be going on and on and on. Helm does this for you and only exposes some configuration parameters that you want to define yourself. Ladies and gentlemen, we've barely scratched the surface. This is just the tip of the iceberg. What I've shown you is a very simple Varnish Enterprise install, but there's so much more going on. And all the configuration parameters, dozens of these parameters, can be found on our documentation website. That's available on docs.varnish-software.com/varnish-helm. You'll find all the configs and also the explanation on how to get all the secrets working, the usernames, the passwords, and there's even information on how to install Varnish Controller, which is our control plane. If you're interested in using it and you're not a client, go to our website and reach out to us. That's varnish-software.com/contact-us. If you're already a client and a Varnish Enterprise user, just reach out to your account manager. And on a final note, you've been asking yourself probably, what about open source? Well, while this is solely targeted at enterprise users, we're contemplating whether we can convert this Helm chart into an open source version. And while I can't confirm anything and can't give you a timeline, it's very reasonable that this will be available for Varnish open source users in the future. Thank you for watching this video. See you next time.